Let us now derive an expression for electrical conductivity. To understand this, let us consider a conductor of length L across which an electric field E is applied. This capital E here. Now, because of which the electrons will move with the average velocity called as drift velocity. Now here what we'll do is we'll find out as to what is the relationship between conductivity and electric field. To understand this, let us consider that small n, which is called as number density, which is equal to number of electrons per unit volume. So we consider conductor where n is its number density. Now here, suppose some electrons, in a given time delta t, the electrons start from here. Let us assume the electrons enter from here, and then in time delta t, the electrons cover this much of a distance. So since the electrons have an average speed called as Vd, in a time delta t, the electrons will cover a distance which is Vd into delta t. So this is distance covered I hope it's visible, distance covered by electron in time delta t. If this is the distance covered, then the volume covered would be this distance into area of cross section. So it will be Vd delta t, that is the distance into area of cross section, which is taken as capital A. So capital A is the area of cross section. Now let us find the number of electrons crossing in a given time. So number of electrons crossing this region, that is number of electrons crossing this region. From this formula it will be number density into volume. So number density is small n as it is, which is a constant for a given conductor, into volume. So volume is this total volume, which would be area into length, which is A, and length would be Vd into delta t. Keep in mind that here we're taking only the magnitude of drift velocity. So this is number of electrons crossing, which I call as some n suffix e, just notation, nothing beyond that. Then find the charge crossing, which I call as capital Q. This charge crossing the given region in time delta t would be number into charge. So it will be number of electrons crossing into charge of each electron, because we learned in first chapter that Q is equal to plus or minus n into E, where n stands for number of charge carriers. The idea of n is different here because here n stands for number density, but Q is given as number of charges into its charge value, that is equal to Na Vd delta t into E. This is the charge crossing. By definition of current, we know that current is equal to charge crossing a given region or given cross section in some time. So when you put it here, charge is capital Q, the time what we take is delta t. Therefore from here we get Q is equal to I into delta t. Sorry, that is correct. So from here we write Q is I into delta T. When you put it back here, or when you compare these two, then I into delta T is equal to NA VD delta T into E. From here delta T gets cancelled. Therefore, the current I is equal to NA VD into E. So this is the form for current. But we know that VD is equal to EE tau by M. Putting it back here, we get I is equal to N into A into VD is EE tau by M into small e. Therefore, I is equal to NA E square tau by M into E. If you bring this capital A down, then I by A is equal to N E square tau by M into capital E. But by definition, this was called as current density. Therefore, we can say the current density, which is J, is equal to, now for a given conductor, small n is a constant and even E remains constant, which is charge of the electron. Even this remains constant, it is square term here. And for a given conductor, tau also remains constant because tau is the average value and even n remains constant. So the whole thing in bracket is a constant. We can call that as sigma. So what we get here is J is equal to sigma into E. In vector form, we can say vector J is equal to sigma into vector E, where sigma is called as conductivity, that is given as N E square tau by M. The same thing was derived using Ohm's law alone, where we got the same form, but there we didn't know what is the form for sigma, and this is a more general expression which tells us what is value of sigma also. So this is the relationship between current density and conductivity.